Good day, class, and welcome to SVG 201, Fundamental Surveying. Today we are looking at the topic, the general principles of surveying. There are principles that guide operations in surveying, and we want to look at 3 of them now as we progress. The first one is the principle of working from the whole to the part. Working from the whole to the parts. If you have a very large parcel of land to observe, to work on, for example, something like this. If you start your survey from any portion of this parcel and you go to those points to coordinate this point. Assume you want to coordinate these 2 points. Somebody can as well start his own here and go like that. Starting from somewhere here. The person A who works to coordinate this point will get different value from somebody who started from B. Somebody can start from here as well and go anyhow to coordinate this point and this point. The values gotten by C will be different from those by A and B. The best way to avoid such is to first determine the whole area, the boundary, the points of the boundaries, the whole area. That by carrying out the survey holistically, normally there's no way you can work without error. But in surveying, we have degrees of errors, those that are permissible and those that are not permissible. So, this is only the permissible ones that we can adjust, that we can accommodate. The ones that cannot be adjusted, we term them mistakes or gross error. And we don't even bother ourselves to carry out any adjustment on that. In this case now, if you work holistically around the whole parcel, from the whole, if there's any error in the course of carrying out this work, you can adjust it if it is within the permissible limit. And once you adjust it, you can spread the error on all the points 1, 2, 3, 4, 5, 6. Distribute the error all over. It means that if anybody has any reason to carry out any survey within the parcel, you want to determine any other point, scatter all over. If you take off from any of the corners, not to locate this point, or any point within the whole parcel, you are most likely to get the same value, or very close to each other. And that is why it is advocated that we carry out our survey based on the principle of the whole to the parts. So if there's any error, we can be able to locate it and curtail it. Another principle in survey, or before I go to that, so if you want to, for example, want to carry out survey in Ife, in OAU campus, and you want to fix it within the framework of the Osun State map, you need to first carry out the mapping of the boundary of Osun State, then break it down into local governments, and before you now come to Ife Central. Yeah. So we have the boundary of Ife Central, then you have that of OAU. Yeah, but if you pick that of OAU alone, and somebody else does his own work at maybe Ife Odon, and any other place, there will be problem, there will be complexity. So to avoid that, it is advocated that we start working from old to the past. Now let's go to the second point. The second one is to locate a new station by at least 2 measurements, linear or angular measurements. In surveying, if you want to determine any location, minimum of 2 measurements are required. Though they vary, so there are 2 measurements that you have to measure, at least 2. It can be more than 2, but the stronger, the more measurements you carry out, the better the result is likely to be. Then the third one is provision of adequate checks. Now go back to this one, okay? So you can read more about that in the note. Then provision of adequate checks. Let me explain that one again. You know, most works in the capital project or in building environment depend on surveying. Surveyors are always the first people, set of professionals to enter into a site, and the last to also leave that site. So in carrying out his own work as a surveyor, he has to ensure that utmost care is taken to avoid error, because other professionals are likely to build on the error committed by a surveyor. That's why surveyor has to provide checks to his work before it will become problems later. Take for instance, somebody wants to build, bought a piece of land and he wants to build a very mighty, gigantic building on that land. And they ask the surveyor, help us to determine the size and the shape. So going around, assuming the plot of land is like this, and call it 30 by 18 meters. If the survey is not well carried out and the measurements are not correct, peradventure, the surveyor put this one as 25 meters, or let's say 35 meters, where in real sense is 30 meters. He put it as 35 meters, while in real sense is 30 meters. And this one possibly put it also at 22 meters, while in real sense is 18 meters. In that situation, the survey plan is produced, is prepared, and given to an architect to design. The architect will make his design based on the drawing available to him at 35 meters and 22 meters. While in real sense is 30 meters by 18 meters. He would have put all those ones into consideration, the setbacks and all that. By the time they get to the field, when they want to do the actual setting out of the building, there will be a problem, because what was designed will be bigger than what is reality. Therefore, adequate checks must be carried out by surveyors to ensure that he produced a very accurate survey plan, because other professionals will build on it. When you look at it, maybe they want to sell the land, and say this is the size. But meanwhile, it is not up to that. Somebody will have to lose money, whether you pay more than what is required for that land, or you pay less, based on what is given to you. So, at every stage of surveying work, checks are produced. Then the third one, and so you can see checks there now. If you measure, for example, if I measure this square, this rectangular shape, I need to check if this is 35 and this is 22, 35 rather, and 22. If you have measured like that, there's nothing wrong for you if you have to measure the diagonal to check it. And by Pythagoras as well, you can also check 35 squared minus 22 squared, plus 22 squared, to give you the square root of this. The square root of that will give you what you should have there, in case it's a perfect rectangle. So, but you can check on the field as well. When you check on the field, note it. So by the time you finish plotting, you will be able to see it. Whether you measure what you measured in the field tallies with what you have plotted. So that's why you see the check line there. So another one, the other principle upon which surveying stands is the location of new station by at least 2 measurements from fixed reference points. Measurement, the location of new station by at least 2 measurements from fixed reference point. Look at this now. If I have this point already known, call this one point A, call this one point B. If I want to fix another point here, because we normally work from known to unknown, no survey stand in isolation. Before you can know every preposition where you want to determine, you must be coming from somewhere. In surveying, we provide information, adequate, unconfusing information about location, that anybody at a time can say this is where I am at a particular time. So if you don't know where you are, you must know where you are coming from. So in order to know the new position, there must be 2 points of reference. This A is known, this B point is known, but this point C is not known. In order to locate this point, in order to fix this position and to describe it very well, we can go this way. You can take an offset perpendicular line from this to this. So it means here you take angle, this angle there, then you take measurement, distance from here to here. Once you know the angle this one is coming from here, or you know the distance from here to here, and the angle, then you go to this point, you can fix this point C. Now I'll show you some other ones. Okay, this method is what we call offset. Offset is when the time we mention offset. Now the first one I mentioned is offset. Look at this, for example. Now look at this, for example. Position C is to be determined. You measure CD at right angles to AB. This AB is known already. This line is known. Then at a point D, actually if you are going from A to B, you know at a point you get to D. And from that D, you go in the right direction, 90 degrees, in order to locate C. So you know the distance from D to C, and you know the angle last separation. So that is one, that's offset. Then another one is, come up there. Now another one is this. By taking ties. In this case, whenever you take ties, you carry out 2 measurements from known point. Look at A, B. We want to locate C. From B, you can measure distance to this point. From A, you can measure distance to this point. When you measure 2 distances from 2 points from your reference line, this is a reference line, known point or baseline. When you take measurement from your baseline to a point, take 2 measurements, 2 or more measurements. Then what you have done is taking off ties. You can be more, it is minimum of 2. You can be more than 2, it can be 3. You can decide to take another one from here to that location. I told you that minimum of 2 measurements are required. But in this case now, here we have combination of linear and angular. This one is purely linear. From B to C, from this one to this, and this one to this. At the intersection, we'll give you that point C. So that is another way. Another one is taking traverse surveys. In this case now, traverse survey, you can look at it from this diagram. This A and B, as usual, they are known. But you want to fix this point C. This traverse survey is more reliable, more accurate because of the equipment you are using. You use theodolite traversing. Sometimes you can use compass, but theodolite is more accurate than the other one, than compass. We'll get to know more about this as we proceed in the lecture. Look at it now. A, B, they are known points. We don't know C. When we say points A and B are known, it means they have coordinates. Coordinates are values that we use in representing a position, and that is unique to every position on Earth's surface. So from A, which is known, you measure an angle with your equipment, usually theodolite, then you measure distance to this. In this case now, we have combination of angle and distance. So that is another way. The next one is intersection. The one I've explained now is traverse. This other one is intersection. Intersection, you can you just measure angular something. Let me make the other diagram here. By intersection, you also have the points known A, B, and C. You don't know C. A is known, B is known, but you don't know C. By intersection, since you have this one, you observe to this angular measurement, call it θ1. From this reference, you set your equipment here. You also measure the angular separation of this line from this line. Call this one θ2. When you shoot ray from here to this line, you just draw it like that. You don't bother yourself about distance. And from here, you will also shoot ray to C, knowing the angle between here and there. The intersection of the rays will meet at point C, because you are targeting just one point C. So you just shoot ray, and this is normally used in a place that you cannot that are not accessible. For example, in a swampy area. In a swampy area, you don't want to carry equipment to the location. And let's assume this is a swampy area. You can only send your assistant to the location, and you cannot draw. You cannot be drawing tape because of the swampy nature of this environment. What you do, send up another day, provided they can get to the location, then you stay there with surveying equipment, a reflector, to receive his signal from you, measure. This is on the shore, whereby it is on a stable ground. So at this point, you just shoot ray to this, and you note the angle here. Shoot ray from here, you know the angle here. Even me looking at it, by the time you can estimate the theta here 3, because it's going to be θ3 will be 180 minus θ1 plus θ2. With that alone, you can know the angle here. And since you have known the distance from here to here, you can determine what is going to be the angle here, 1. You can know the distance here. You can know the distance here if you use your sine formula. Sine formula, with sine formula, you can determine the distance here and distance here. And with your cosine formula rule, you can determine all those points. So that method is what we call intersection. So you will see that in this case now, only purely angular measurements were carried out without distance measurement. So that is that. Now I want to go to another